This is Unit 3B. It deals with velocity, acceleration, and speed. So starting with the idea of speed, we have distance per time, and then we have velocity. And to get velocity, we also need the concept of direction. Now over here we've got 4 cars. All of them have the same speed. They're all going 100 kilometers per hour. But as we can see here, this grey car has a different direction to the rest. And we indicate that with the minus sign. Now, we can indicate direction with lots of words: left, right, up, down, north, south, but plus and minus are the most frequently used ones here. Obviously we can see what's going on here, but if we had to write it down, this would be a clear way of doing it, because the minus would indicate the direction. Now if we add the concept of time again, we get the idea of acceleration. So this is how quickly is your velocity changing. In common sense language, we have the idea of speeding up, slowing down, or changing direction. Now we have 3 graphs here, and whenever you get a question like this, it's really important to look at your y-axis. These graphs will look similar, but be very careful what's on your y-axis, because you'll get confused otherwise. So working our way up from the bottom, we've got a strong acceleration here, a less strong positive acceleration, we've got 0 acceleration, negative acceleration, and then we've got changing acceleration. So let's see what effect that has on our velocity. Here in this first section we've got an upward sloping line, a steeply upward sloping line. Here we've got a less steeply upward sloping line, so the velocity is still changing but less per second. We have a flat line here indicating that the velocity isn't changing, so no acceleration. Here we can see the velocity decreasing, which is our negative acceleration or slowing down. And then finally we have our curve here where the velocity is constantly changing because the acceleration is actually changing itself. Now it's important to remember that, as I said earlier, this does not represent the height in this situation. Be very careful. It's an abstraction. It can be confusing. So remember, in this case the distance is always going up because the velocity is always positive. Always going up. We can see that the rate at which it goes up changes. For instance, we've got a straight line here indicating constant velocity, but make sure you don't lose track of the reality of the situation. So if you want to calculate acceleration a bit more accurately rather than just saying strong or gentle, we have a formula here. Acceleration is velocity change divided by time taken. So we've got v, which is our end velocity, minus our start velocity, and that gives us our change in velocity, divided by the time taken. And here we've got the worked example, and that gives us 3 meters per second per second. Now it's quite a strange unit, but it does make sense. It says every second we are gaining 3 meters of speed. So there we have it, velocity and acceleration. The key ideas are here: speed, velocity, and acceleration. Every time we're adding in a concept, we're adding in direction, and then we're adding in time again. And our common sense explanations are here: speeding up, slowing down, and changing direction.